Welcome to the deep dive. You know those incredibly sharp space pictures we see? You ever wonder how ground telescopes pull that off?
Yeah, especially with our atmosphere getting in the way.
Exactly. So today we're looking at the Paranal Observatory in Chile. Specifically, one telescope, the UT4, part of the very large telescope setup.
And this one's pretty special. It doesn't just look at stars. It makes its own, sort of.
Makes its own stars. Okay, that sounds like sci-fi. What's going on there? Is it about cutting through that atmospheric shimmer?
Precisely. That shimmer, atmospheric turbulence, it blurs everything. So UT4 uses this clever laser system to fight back.
Lasers creating stars. How does that even work up in the atmosphere?
Right. It's got this thing called the 4 Laser Guide Star Facility, 4LGSF. Basically, 4 powerful laser beams shooting straight up.
Okay, 4 beams. How high?
Way up. About 90 kilometers, give or take. There's a natural layer of sodium atoms up there.
Sodium atoms. Where do they come from?
Mostly from meteors vaporizing as they enter the atmosphere. Tiny remnants just hanging out up there.
Huh. Okay, so the lasers hit this sodium layer. Then what?
They excite those sodium atoms, make them glow brightly, and boom, you've got 4 tiny artificial points of light way up high.
Artificial guide stars.
Yeah.
Created by the telescope itself. Clever. But, why? What do these fake stars tell you?
They're perfect reference points. Because we know they should look like tiny, steady points, we can see exactly how the atmosphere messes with their light on the way down.
Ah, so you watch how the fake stars twinkle, basically.
Exactly. You measure that distortion very, very precisely. It tells the telescope exactly what the turbulence is doing, moment by moment.
And that's where the really clever part comes in, right?
Yeah.
Fixing the view.
Yes. This feeds into the adaptive optic system. UT4 has a secondary mirror that's, well, it's flexible.
Flexible, like it wobbles.
In a highly controlled way. It can change its shape subtly, thousands of times a second, based on what the guide stars are telling it about the atmosphere.
So if the atmosphere makes the light zig, the mirror makes it zag to compensate.
That's a great way to put it. It actively cancels out the blur.
And the result? How good are the images?
Astonishingly good. We're talking images taken from the ground that can rival the sharpness you get from space telescopes like Hubble.
Wow, from the ground. That's huge. Any cool examples?
Definitely. Think about studying exoplanet atmospheres. This sharpness lets us tease out faint chemical signals from planets orbiting other stars, stuff that was impossible to see clearly from Earth before.
Amazing. So this isn't just a UT4 party trick then. Is this tech spreading?
Oh yeah, absolutely. This is becoming key. The other 3 main VLT telescopes, they're getting lasers too. It's part of an upgrade for the VLT Interferometer.
Interferometer. That's linking the telescopes together, right?
Exactly. Combining their light to act like one massive virtual telescope. The Gravity Plus instrument is part of that, and these lasers will make it way more powerful.
So some more lasers, linking telescopes, creating an even sharper eye on the sky.
That's the direction. And think bigger picture. The extremely large telescope, the ELT that's being built nearby.
Yeah, the huge one.
It's planned to have at least 6 lasers right from the start. The future is definitely about using this tech to overcome the atmosphere.
So telescopes aren't just passive observers anymore. They're actively, engineering their own view. Pretty incredible what ground-based astronomy can do now.
It really is pushing the boundaries. Which makes you wonder, doesn't it?
What's that?
Well, think about it. As we get better and better at essentially removing the atmosphere from our view, seeing deeper and sharper from right here on Earth, what completely unexpected things are we going to find out there? How might this clearer vision change our whole cosmic perspective?